In this video, we will calculate rigidity modulus of the material of the rod in the static torsion apparatus, that is the Sial's apparatus, and scale and telescope is used to measure the twist here. So these are the experimental observations. Here the scale readings will be taken by rotating the thread in clockwise direction as well as in the anti-clockwise direction. So first we'll look into the clockwise direction scale readings, then in the anti-clockwise direction. See, for the dead load W in the clockwise direction, we have a set of reading for loading and unloading. For loading it is 29.9 and for unloading it is 29.8. So to get the mean of that, you add these two scale readings and divide it by 2, you will get mean as 29.85. Then a 200 gram is added. For W plus 200 we got 30.9 and 31 for loading and unloading. Then mean is 30.95. And W plus 400, the scale reading is 32.2. For loading and unloading it is 32.5 and the mean is 32.35. In the same way, till W plus 1400, the scale readings for loading and unloading are averaged and it is 38.4 for the last reading. So for the clockwise direction scale reading mean is taken as X. Then the next set of reading is in for the anti-clockwise direction. For loading we have 27.2 for W and unloading it is 27.3. When we take the average of these two, you will get 27.25. And W plus 200, the loading and unloading value in the anti-clockwise direction is 26.2 and 26.1 respectively, and the mean of this is 26.15. In the same way, we can calculate the average of the scale readings till W plus 400, and for the last reading the average value is 17.9. See, from the readings reading for the clockwise and anti-clockwise direction, we could see if in case the scale reading from W to 1400 decreases or increases in clockwise direction, then in anti-clockwise direction the scale reading will decrease from W to W plus 1400. So even in this reading you could see in clockwise direction the scale readings keep on increasing as the load increases, and in the anti-clockwise direction the scale reading decreases as the load increases. So we have the values X and Y. So next we have to calculate what is X difference Y divided by 2. So X difference Y means X may be a bigger number, Y may be a bigger number. What we have to do is we have to subtract the smaller number from the bigger number. That is what X difference Y stands for. So here the bigger value is 29.85 and the higher value is 27.25. So take the difference of these two and divide it by 2, you will get 1.3. In the same way, for W plus 200 it is 30.95 minus 26.15. The answer is 2.425. For the last reading, it is 38.4 minus 17.9, you will get 20.50. When you divide it by 2, you will get 10.25 for W plus 400. So next we have to find out shift. Here we are going to find out shift for a mass of 800 grams. In SI unit, it is 800 into 10 power minus 3 kilograms. We can find the shift for 600 grams or 1000, that is 1 kg or 1.2 kg. Here I have taken or found the shift for 800 grams. See, when you subtract the X difference Y divided by 2 value of W plus 800 with W, see, which is highlighted in red colors. The W is highlighted in red color and W plus 800 is highlighted in red color. When you subtract this value, you will get 5.2. For the next set is W plus 1000 minus W plus 200, that is 7.75 minus 2.425. You will get 5.325. The next value, which is highlighted in blue, W plus 200 minus W plus 400 minus W plus 400. Again, it is the shift for 800 grams. So it is 9.2 minus 3.725 will give you 5.475. And the last set of readings, W plus 1400 minus W plus 600. Again, the shift for 800 grams, that is 10.25 minus 4.875 will give us 5.375. So in the last column, we could see all the shifts are almost around 5.3. So we can average out. When you add all these 4 reading, you get 21.375, and when you divide it by 4, you will get 5.343 into 10 power minus 2 meters. So this is the shift for 800 grams. So next is to find the radius of the rod using screw gauge. We have discussed the calculation of the of finding the radius using screw gauge in many experiments. So here the pit scale reading is 5, the head scale coincidence is 86. So the correction here is the positive error, and the correction is negative correction, so minus 3 divisions, so it is 83. When you multiply it by least count, it is 0.83. So the total reading, which is the sum of pit scale reading and the corrected head scale reading, so it is 5 plus 0.83, you get 5.83. For all the 5 readings, you have to add and divide it by 5. You will get the diameter of the rod, which is 5.818 into 10 power minus 3. We should be very careful. Many people used to substitute the diameter for radius. So you have to divide the diameter by 2 to get the radius, which is 2.909 into 10 power minus 3 meters. Then some of the observation we would have got from the experiment, that is the distance between the fixed end and the mirror, which is capital L, is 23.5 into 10 power minus 2 meter, and the distance between the scale or the telescope and the mirror is D, it is 92.5 centimeters. Then the circumference of the wheel, which is 2 pi r, it is about 42.7 centimeters. To get the radius of the wheel, the circumference is divided by 2 pi, so that you get capital R, that is 42.7 centimeters divided by 2 into 3.14. So you get capital R equal to 6.79 into 10 power minus 2 meters. Now let us calculate N, and the shift we have obtained for 800 grams. So it is M is equal to 800 into 10 power minus 3 kilogram. G is 9.8, L is the 23.5 in 10 power minus 2, D equal to 92.5 into 10 power minus 2 meters, R is the radius of the wheel 6.29 into 10 power minus 2 meter, pi the constant, we know 3.14, and A is the radius of the rod 2.909 into 10 power minus 3 meters. Yes, the shift just 5.343 into 10 power minus 2 meters. To get a correct answer, what we have to do is, you have to write all the notation in terms of the SI units, that is with the powers. So if you get it, all the parameters in correct powers, write it in correct powers, then the calculations are easy to do. So the rigidity modulus N is given by 4 mgrld divided by pi a power 4. Yes, this is the formula. Let us substitute all the values in the formula. So 4 into 800 into 10 power minus 3 into 9.8 into 6.29 into 10 power minus 2 into 23.5 into 10 power minus 2 into 92.5 into 10 power minus 2, the whole divided by 3.14 into 2.909 into 10 power minus 3, the whole power 4, multiplied by 5.343 into 10 power minus 2. In the next step, what you do, you write all the numbers first, then write the powers at the end. So you get 4 into 800 into 9.8 into 6.28 into 23.5 into 92.5. Then the powers 10 power minus 3, 10 power minus 2, 10 power minus 2, 10 power minus 2. In the denominator you will have 3.14 into 2.909 into the whole power 4 into 5.343 into 10 power minus 12. That is 10 power minus 12 comes from the radius, that is a power 4. So 10 power minus 3 the whole power 4 will give you 10 power minus 12 into 10 power minus 2. Then multiplying all these numbers we get 428781752 into adding up all those power minus 3 minus 2 minus 2 minus 2 will give us 10 power minus 9. And in the denominator multiplying all the numbers you get 1201.40 and adding up the powers you get 10 power minus 14. In the next step, divide the numerator and the denominator. You will get 35690.7413 into 10 power minus 9, and taking the powers in the denominator to the numerator you will get 10 power 4. So adding up, bringing the decimal points in the front direction, so you'll get I'm pushing the decimal point to 5 places. You will get 3.569 into 10 power 5. Then on the adding up the powers 10 power minus and 10 power 14 will give us 10 power 5. So we have two 10 power 5s, which adds up to give the rigidity modulus of the material of the rod to be 3.569 into 10 power 10 Newton per meter square. This is the required result of the experiment.